You are given an image represented by an m by n grid of integers image, where image ij represents the pixel value of the image. You are also given 3 integers, SR, SC, and color. Your task is to perform a flood fill on the image starting from the pixel image SR, SC. To perform a flood fill, begin with the starting pixel and change its color to color. Perform the same process of each pixel that is directly adjacent and shares the same color as the starting pixel. Keep repeating this process by checking neighboring pixels of the updated pixels and modifying their color if it matches the original color of the starting pixel. Process stops when there are no more adjacent pixels of the original color to update. Return the modified image after performing the flood fill. So all this really means is that we're given some image and some coordinate in this image. We're going to be looking adjacent, which just means up, down, left, or right. And if any of those adjacent cells have the same value as our original coordinate, we're going to be changing them to the new color. And then if any of those cells have that same color, we're going to be changing all those adjacent cells to that adjacent cell to that new color. So for example, we go from this one to this one, and then because this one has the same color, we're going to be looking at these 2 cells as well. And after we finish our flood fill, we get this image. Why doesn't this one change? Because in our original image, we could not go from here to here, and then we could not get from here to here. So this one remains unchanged. So what's the actual algorithm for this problem? We're going to change this color and then add all of its adjacent cells to a queue to also be changed and repeat the same process. So when this coordinate is next in the queue, we're going to add all of its adjacent cells after changing its color. So we'd add its up, down, left, and right. Clearly, its up doesn't exist and its down had already been changed. So we'll need to think of ways to account for this as well. So let's start getting into this. First, let's get the original color. Original color equals image SR SC. And let's add this original coordinate to a queue, but let's just call it Q equals Python list initialized with SRSC. And we're going to say while Q, which just means while the queue is not empty, we're going to be repeating this while loop. Let's first get the first element of the queue. So current elements equals Q.pop. I'm assuming SR and SC just mean start row and start queue. So let's just change this to row equals the first element of current, C equals the second element of current. And now if that color equals the original color that we first had, we're going to change it to the new color. So if image RC equals original color, image RC equals color, and then we add all of the adjacent cells to the queue. So Q.append RC, and then we just add +1, +1, -1, -1. And then once we're done, we'll just return the image. But we're still not done. We need to consider the case where we're here and we add a coordinate that's out of bounds. So we're going to say something like this. If 0 is less than or equal to R, and R is less than the length of our image, and 0 is less than or equal to C, and C is less than the length of image 0, then we're going to perform all of these operations. So if it's in bounds, we're going to perform these operations. So what exactly does this portion mean? Our rows are these inner values. So that means it's just going to be the length of this. And our columns are just going to be the length of that first element. We choose the first element because we always know it's going to be there. And again, if this doesn't really make sense, think of it like this. This is just an array of arrays, but it can be an array of anything. We could just say 1, 2, 3, and that would be our rows in this case. To substitute each one of these values with something that would be more understandable for you to see that the rows is just the length of the image. And we have to make sure to put this in our if block here. Otherwise, every time a index is in bounds, we're going to add it to the queue, and that's not the case. We should only add it to the queue when it has the original color. So we're really close. And if we try to run this now, we get a memory limit exceeded. And this actually comes from our second test case. Let's consider this case. What actually happens here? We start on this index and we change this color to the new color, which is 0. We're changing its original color to the same color. And then we move up, down, left, and right. So when we get here, after we change the color, we go up, down, left, and right again. And we're adding this value back into the queue. So what happens with our test case is that we keep adding values back into our queue such that we just run out of memory. So many zeros are being added to our array that we just crash our program. So that's why we get this memory limit exceeded. It's because we keep adding values back into the queue. So how do we resolve this? Our main issue is that we just keep changing our color to the same color. So instead, what we're going to do is we're going to change it to a different color. And what color are we going to pick? We're going to pick some color that's outside of our constraints. So we know that our color has to be somewhere between 0 and 2 to the power of 16. So let's change our color to -1. We're going to go through our array, and every color that we change to a -1, we're going to change to the color that it needs to be changed to. So you can think of this as just marking the color to be changed to the new color instead of changing it directly to its new color. So how do we do that? We're just going to change color to -1. And after we exit our queue, after we change everything that needs to be changed, we're going to iterate through the image again. So for I in range len image, for j in range len image 0, if image I of j equals -1, image I of j equals color. So let's run this. We pass our second test case and let's submit it. And there we go. So what's the runtime of this? It's just going to be O of mn. The space for this is going to be O of 1 because we're not using any extra space. A link for this code will be in the description. Please like, subscribe, and let me know which one I should tackle next.